Now let me introduce Innovation Oz publisher, Corey McLeod, who's going to talk us through the next part of the program.
Thank you, James, and thank you, Ambassador. It's great to hear that view from Washington. Hearing directly from Ambassador Sinodinos about what he's seeing himself from a technology perspective is incredibly valuable. Lee and Michelle, thank you for joining us. Lee, I'm going to start just bringing off some of the comments from the Ambassador. You've also said that the AUKUS Pact is a technology arrangement that represents a once-in-a-generation opportunity for Australia's sovereign future industries. We heard about some of them from the Ambassador. What are other future industries we should be thinking about?
Well, thanks, Corey, and thanks to Innovation Australia for including me today. And it's a real honour, of course, to be here with Michelle as well. Look, what we need to make clear, it's not a security alliance, so it's not a security pact. This is a technology transfer and an innovation access and transfer arrangement. And it's really exciting. It's a time of innovation for Australia, and this really is a seminal moment as we really assess how we're going to take this opportunity. So some of those technologies that Arthur Sinodinos just spoke about includes quantum, artificial intelligence, robotics, cyber, advanced undersea systems, digital twinning, robotics. You know, these are technologies that Australia not only in some case owns, but we actually are the leader, a global leader. So that's why I highlight it's actually access and a transfer arrangement. Look, out of this, I think the fundamental questions is what do we own? What do we need to collaborate on? And what do we need to access? Because this is about our sovereignty, our security, our prosperity, and delivering next generation technologies to not only our Australian Defence Force, but across our national security system and wider, in creating that sense of innovation across the Australian system. And we'll talk about, of course, the ecosystem later on.
Michelle, this is a good place to bring you in. You have a global view of the quantum computing landscape. You've been working on the quantum computing in Australia for 20 years. Yep. Where are we? Where are we in the global landscape?
Yeah, look, I think it's amazing that not many Australians recognise that we are actually world leaders in this. We got in 20 years ago when the field was really transitioning from a theory to an experimental realisation. Over that 20 years, we've developed leadership in actually manufacturing and building hardware here in Australia, and then building the ecosystem around it to actually operate those systems. I think it's the Australian research system for 20 years has invested in centres of excellence, which is unique globally. That 100, 200 people working on a particular project. We now have 6 centres of excellence in Australia where quantum is at the core of it, and we've also looked at unique models of translating that research out of those research centres into companies. And so in that getting government, industry, and universities working together, Australia really takes leadership in the area.
We'll come back a little bit more to the world view on quantum, but that goes to a point around ecosystems. Now, as you've been in the Navy for a long time, you've been 12 months out in the Minderoo Foundation, which is in itself structurally quite, interesting. What have you seen about the ecosystem and bringing together those different parts that can really make change happen?
Yeah, thanks, Corey. Just building on Michelle from quantum, of course, that's exciting, that computing power when you think about our hypersonics and we're developing Australia, our guided missiles, our digital twinning, it really will unlock our potential. So it's about our, not only accessing, but our transfer. In terms of the ecosystem, of course, I transferred from a full-time career in the Navy in January. I still, of course, maintain my other service credentials, but really, what I've seen is the ecosystem isn't just the corporates, isn't just defence, isn't just governments, but of course it's the research sector, it's the innovation sector, it's the venture capital sector. When that ecosystem comes together, they can make impact and do things very quickly, and they can unlock potential. So being in impact philanthropy, the Minderoo Foundation, the data, the evidence, the talent is actually drawn in because as a collective, you can make a change very quickly and you can get to the most innovative technologies, not just here in Australia, but also collaborate globally as well.
I think the idea of being able to change things quickly and mobilise talent, is something that we have an opportunity to take a new view with something like the AUKUS Pact. Michelle, you talk all the time, both locally and internationally, that sense of momentum and the sense of ambition. Just springing off what Lee just said, there's a real opportunity to kind of bring some of this to life with a refreshed view of energy.
There is, and I think one of the things that I'm particularly keen on is that we get Australians really at that high technological edge, with data-intensive industries where they're actually building and creating industries here in Australia. We attract people from all over the world. We've just done a hire. We've got people coming from MIT, from CNRS in France, from all the leading groups, from Microsoft, from Delft, wanting to join us here in Australia. So we've got this incredible momentum where people want to go to where the leadership is, and it's an opportunity for us to actually capitalise that, bring Australian students along with it, and actually create those industries now.
Can I ask another question? I think for many people, quantum has been such a long range, full of potential, but in terms of actually realising its power. Can you give us a sense of where the reality is from an application perspective now? Where will we see its application? What are we really talking about in defence, but also other industries that might be looking to future-proof?
Yeah, look, quantum computing obviously allows you to do calculations much faster than you can with classical. So, literally minutes as opposed to thousands of years. And it comes from that massive parallel compute power. Every industry that has data will need it eventually. And so it's a question of looking at what those applications are now. And if you look at each different sector, you'll see in the defence industry, there's huge numbers, whether it's optimization of their troop supplies and their supply chain management, strategic planning for them. It looks at materials design, whether it's materials for the stealth so that they can protect their aircraft, or new battery designs, all the way through to kind of optimization and artificial intelligence, looking at patterns of behavior, signals in the electromagnetic spectrum. And then finally in defense, you're even looking at code breaking. Code breaking is one of the big applications long term where, people can actually see secrets from different countries, and those things are things that protect the infrastructure and the finance systems of those countries. And then if we look at other industries such as the finance sector, we're working with the Commonwealth Bank. They're looking at optimising their portfolios for their customers, looking at risk analysis, watching how to look at the market itself and predict those trends, all the way through to the telecommunications industry and how you get the signals out and the benefit of all the different people in the world connecting together. So, those industries are now engaging. They're actually funding it here in Australia. And going forward, there's huge potential capability in those applications within the next 5 to 10 years.
So that partnerships with those organisations are really about co-creating solutions. There's so much, I guess, you're working on and understanding the power of quantum that...
Yeah, it's still at that stage where it's the late stage development stage, and looking at what those applications are and building the hardware specifically for the end user applications is really starting to happen. And Australia, again, got in at the front. We've got 2 big global corporates that sensed this, 5-10 years ago and partnered with us as it was coming along.
I'm going to ask sort of both of you as a question. One of the things that I understand is that whilst we've had this long history with quantum in this country, we're seeing other countries really kind of rapidly developing their own technologies, and that's been a little bit fast tracked by the industries that are able to pull through the application. So Lee, from what you can see now that in this sort of fresh role, but also with your history in the Navy, how does Australia fast track the industry development to pull through some of these emerging technologies? Because ultimately, the faster we can adapt our own technologies, the faster we can grow them and test them and export them.
Yeah, the first thing, let's not self-deter Australia. Let's be restlessly ambitious, because we actually have the talent and we have the history now, especially with quantum, and it's incredibly exciting, the potential. Not only exciting, it's actually critical that we actually drive through what we say we're going to do. That is attract talent and actually really build on the quantum momentum that we have. Look, I think we can't be conservative here. We need to actually take some risks. And actually, and that's okay, because I think sometimes from a military perspective, I know you're very careful with risk, say in the operational environment, but risk is actually opportunity, and I think we've got to take it. I mentioned at the start about what AUKUS means, about own, access, or potentially collaborate. This clearly is an own, and we need to drive it.
That the notion of risk is very interesting. We hear about it, whether it's about venture capital, whether it's about founders failing. Michelle, we've spoken before about, as a scientist, everything's about testing and failing and moving on.
Absolutely, yeah.
So how do we shift that tolerance for, fast failure and taking risks and pushing through? I mean, that's a big cultural question. Are we seeing change? Are we getting there? Are we understanding that failure is okay?
Look, I think it's slow. It is slow in Australia. There's still that sense that you shouldn't fail, but anyone that is a scientist that's building something knows that that's actually inherent to the success. So you have to embrace failure. It's how you learn and how you do things. And I think now Australia's in a position where it really can transition out of those industries. Looking at what's happening, Lee's mentioned all the different support sectors that are out there, but actually having government, choosing areas of strategic national importance for national security and economic benefit actually does help that.
And that's they're taking a bold approach to where those...
You've got to be bold and ambitious.
And I think David Peever's now leading a review on behalf of Minister Melissa Price, which is going to look at our innovation, our science and technology and delivering these capabilities. But of course, part of that will be about being bold, taking the risks that we need to actually move through. We obviously will get access to the US system and we'll collaborate and we'll actually transfer things to the US system. But we could look at some of their examples. For example, DARPA, Incotel, other systems already in place in the US that potentially have an opportunity here in Australia, not necessarily to replicate, but look how those systems have actually encouraged innovation and the courage to actually take the risk you need to actually drive next generation capabilities.
And Michelle, going back to sort of global view, you're on the American Physics Society
Division of Quantum Information.
That's one. Widely, globally, do people know, is it well known where we have those capabilities?
Absolutely.
It is.
So I'm the chair of that society, and I get to see all across the American system, all the way through the quantum computing hardware chain, from software to hardware and applications. And they know Australia has huge talent, so they see us as a pool of talent that they can take information from. So obviously partnering with them is a good way where both sides get the benefit. In areas where we lead, I think we have to get behind it and show that, as I said, even the schemes of bringing researchers and industry and universities and government together, that is something that the US is still picking up from us. So there are areas where we lead in multiple ways, not just the technology, but the translation of that technology. And I've heard lots of people from the US, and John Martinez came to join us from Google, and he said, I wanted to do what you've done here in the US, but it wasn't possible. So, we've got to own it where we lead and not be shy of it, and continue to lead.
It's interesting, you could sometimes argue that in regards to things like quantum, Australia can be small but perfectly formed, and if we're good at that stuff. So, Lee, previously you were part of a New Generation Navy team and Deputy Director of Transformation and Innovation. Just looking at the view of looking at something like transformation and innovation within defence or within the Navy, and all the things we've been talking to now about bold and ambition and harnessing ecosystems. Are things changing, do you think? What was the view then, and what do you think the view is now?
So that program was 10 years ago, and I think when we used the word innovation, we were just working towards a cliche. I think now, 10 years on, we've made significant progress in terms of a mindset. We can talk about a cultural change, and in defence, of course, that draws certain focus. In terms of actually innovation, wider engagement with the wider ecosystem, and understanding that the best answers aren't inside, they're often outside, and how you actually attract those. So New Generation Navy was about a cultural and a leadership program. But actually 10 years later, I'm proud to say you can actually see that the next generation of Australian Defence Force personnel and all our supporting organisations are far more innovative. We're not there yet. And I think we do sometimes self-deter, and we sometimes put our own limitations and our own glass ceilings on things that we potentially can achieve. And I think sometimes security is wrapped around that, and I think we can be much smarter about how we actually bring in others, because the talent set isn't just in Australia. And we've got to attract the best and the brightest from the globe, and and especially on the areas that we are leading. Just one other comment, just a sense of pride as well. As an Australian Defence Force person, it's a real sense of pride when I talk about quantum and hypersonics, digital twinning, and all those technologies that Australia is leading. You'll find Australian Defence Force people when they go around the globe, they're very aware of it and very proud of that as well. And so we really want to take that forward.
So coming back to you, Michelle, where we're at now, so for the next 12, say 24 months, where is Silicon Quantum Computing at as a company? What's the future looking like in the kind of medium term in terms of quantum in this country?
So we're absolutely gunning to build a processor here in Australia. A lot of people think you need a multi-billion-dollar manufacturing industry to build it. We can actually build it here without that. So that's something we're very excited about. But yeah, we're on the mission to build what we call a 10-qubit quantum integrated circuit, our first minimum viable product, about 100 qubits within 5 years, and then to build the industry around it, using literally hardware, software, engineers at every level. It's going to create a whole new transformational computing industry here in Australia.
We've got 2 minutes left, and I just wanted to use it because it's sort of been implied in the conversation we've had today, but the idea of sovereignty. Sovereign capability, what we can have here, where we found some of those, fragile supply chains throughout the COVID pandemic. So, Lee, you'll have seen, sovereign capability obviously is vital to, defence. Where are the areas that that you may have seen even through the work with Minderoo right now, from sovereignty that we really need to own? And Michelle, I'll ask you the same question. Quantum's obvious, but will it be others, I'm sure?
So sovereignty is one word. I think self-reliance. And the reality is the strategic situation has changed. So Australia needs to stand up and actually do the things it needs to do to reflect the strategic situation. Of course, our own sovereignty, a sense of pride, and obviously generating innovation and jobs and work for Australians, but also because we need to be self-reliant because the situation has changed. The only thing I'll just end with Minderoo, of course, is this sovereignty and self-reliance means the talent's here, and we're very keen to use much of this technology is dual-use technology. It's not just for defence and national security. We've got to adapt to climate change. We've got to clean up our oceans. We've got to observe certain parts of the world. For example, I search for MH370. I'm looking forward to advanced undersea systems, so we actually can really discover the Indian Ocean in full. So that dual-use technology opportunity is just terrific.
There's a lot of ambition to be applied to a lot of challenges and opportunities. Michelle, sovereignty from your perspective.
Oh, look, I look at it really from the kind of educational side all the way through to industry. So we've got to get in and support our maths and physics teachers at schools. We've got to bring those through, support the fundamental research at universities so that they can create those technologies, figure out how to translate well, get behind the companies that are out there, strategically picking where we lead and getting behind those corporates. Obviously quantum computing is one of those areas, but I look across Australia, there's many areas where Australia leads, and it's got to identify where they are and accelerate them.
Lee Goddard, Michelle Simmons, an absolute delight to talk to you today. Thank you both so much.